Hey guys, let's talk about this is someone Shobana BT. Let's talk about this topic. That is design of an intelligent and personalized e-learning framework using machine learning technique. Here, she belongs to Anna University. I think this university is in South. So in this research, she talked about design of intelligent and personalized e-learning. What is the meaning of intelligent and personalized e-learning? Meaning is that if anyone wants to learn in its own way, then this framework this framework designed by Shobana BT will help he or she learn in its own way. That's why she decided to to draw this framework using machine learning technique. So let's deep dive into it and see what's good in it. Okay, see the she just first slide of this PPT. She just shows the one size fits all approaches major snag in e-learning. She's talking about uh, uh, she's talking about like one size fits all approach right now is using in this area. So what is that? Let's go with the sentences. Current e-learning system primarily focus on harnessing ICT. Yes, right, because ICT is used for every e-learning things. Means e-learning is known as ICT. Whenever we talk about ICT, then whenever we talk about the e-learning, then this comes the answer comes as ICT, information and communication technology. This is e-learning, but actually it is not. So going beyond to this, harnessing ICT to deliver learning content in similar formats to all learners, regardless of individual differences. Yeah, she just arises that every human being have their individual differences, and she just told that based on that, she will try to create a framework for the learning. This approach fails to account for diverse learners' characteristics like styles and needs, limiting the effectiveness of online education. Right. The research addresses a critical question: how can we move beyond generic content delivery to create a truly adaptive and effective learning experience? Yes, she raises a very good question. Let's go beyond. A two-part solution, an integrated framework for intelligent learning, I think it's repeating intelligent learning is twice. This research proposes a novel e-learning framework that incorporates intelligence into both instructional delivery and assessment. Yes, she's talking about two blocks. It is built on two core innovation. Okay, the intelligent assessment tool, yes, and the second is personalized content delivery. Okay, moves beyond simple right or wrong scoring to evaluate the real knowledge acquisition level of learners by analyzing non-verbal behaviors. She uses non-verbal behaviors to analyze, and based on that, the assessment tool will be presented to him or her. And in the second part, she focuses on personalized content delivery, a dynamic system for tailors instructional content to individual learning style, creating a truly personalized learning path. Okay, this both comes and together this is called as adaptive e-learning experience for the users. Now, traditional online assessment failed to capture true understanding. Yes, this is right. Multiple choice question MCQ assessment are common but have significant flaw that create uncertainty about learners' actual knowledge level. Yes. Random guessing, no confidence measure, ignores cognitive states. Yep. She raises these 3 points that right now currently faced by the students of the students of Gen Z or Gen Alpha. Okay. Now going beyond, a correct answer does not guarantee comprehension. It could be luckily guess. Yes, this is random guessing. As like it, the no confidence measures the system cannot distinguish between confident quick answer and hesitant one chosen after multiple changes. Okay, yeah, this is describes about the no confidence measure whether he is in confidence or not. Ignores third point is ignores cognitive state. The learner's focus, confusion or distraction during the assessment is completely invisible to the system. This research addresses these issues by analyzing the learner's non-verbal behavior during the assessment activity. Okay, now going to next part, architecture of this intelligent assessment tool. Yeah, she's talked about the architecture. Now if here you can say in the diagram that is learner is in the front of desk, he's learning. Now he's focusing on quiz UI, and quiz UI is the interface of the learner, but in the real time the camera is focusing on to him, and what's camera is doing is blink is detecting the blinking rate of detection module. Yeah, it is capturing the blinking rate. Thereafter one more is body posture estimation, and third is emotion recognition. Fourth is confidence score and clocking time module. Okay, these are the 4 modules. Based on these 4 modules, she's going for the machine learning classifier for final prediction. Okay, and thereafter she validated the knowledge level. Okay, going more, decoding learners' behavior through non-verbal cues, eye blinking rate, body posture estimation, emotion recognition, and confidence score. Based on that, she will track the behavior of the learner. Okay, in eye blinking rate, facial landmarks are detected to calculate the eye aspect ratio. Changes to in blink rate indicate shift in cognitive load, arousal, and memory function. Emotion recognition, a Haar cascade classifier detects the face and an exception model classifier expression into categories like happy, neutral, sad, or surprise, like that. Body posture estimation, the Manhattan distance L1 norms is calculated between consecutive video frames. A high distance score indicates significant movement, suggesting distraction or stress. And then the last is confidence score. Based on these, the system track mouse click. No, these are not based on this. This is separate. Confidence score is based on the mouse track. The system track the mouse click pattern, and a single click on correct answer yields a 100% confidence score, while multiple clicks on the different options before settling on an answer lowers the score. Okay. Now going beyond this, ensemble machine learning accurately predict the true knowledge. Okay, a data set was generated from 500 learners creating features vector from their non-verbal cues for each of 1000 10,000 questions instances. 500 learners into 20 questions. Okay, various classifier was tested. A stacking ensemble model combining XGBoost, random forest, and KNN achieved the highest prediction accuracy key result. The model can differentiate between a correct answer. The model can differentiate between a correct answer based on the knowledge and one resulting from lucky guess, allowing the system to award marks more reliably. Okay, agent decision logic. If the answer is correct, model prediction is knowledge and action marks awarded. Okay, if the answer is correct, but it is guess, so mark is not awarded. Okay, if the answer is incorrect, then lack of knowledge and no mark is awarded. Alright. Now, classifier prediction accuracy based on the classifier stacking XGB, RF, or in KNN. They are together showing the high accuracy classifier prediction. Thereafter, engineering personalization matching content to the learner. The second pillar of the framework is a system that delivers personalized content by understanding and adapting each learner's unique style. This is achieved through two key components. What are they? There is repository of learning objects. First, second is personalized learning path. Learning objects LOS. Course content is broken down into small, reusable, self-contained digital components, example videos, text simulation quizzes, that can be arranged into custom lessons. Learning style modeling. We use a validated model to profile each learner's preference, creating a blueprint for personalization. Learning style model. We use validated model to profile each learner's preference, creating a blueprint personalization. Okay, the Felder Silversman learning style model, FSLSM, provides the blueprint. The FSL, the Felder Silverman learning style model, is used to classify the learner's preference across four key dimensions. This model is highly suitable for web-based learning and forms the basis for both learner and the content profiles. Okay, so going further, we can see here processing, the active and the reflective, learn by doing or group work, learn by thinking, solo work. Okay, input is visual, prefer diagram chart, verbal, prefer spoken words. Okay, understanding, sequential or global, that is linear, step by step or holistic. Learn in leaps, perception, sensing, concrete facts, intuitive, abstract theories. As like the second part, I think is too much tough, but not too much. Going further, right, the content personalization algorithm, an adaptive cycle, profile learner. An initial learner profile LP vector is created using 44 item FSLSM questionnaire. Okay, got it. Thereafter, retrieve and score LOS. Okay, the system the system retrieves relevant learning object and uses cosine similarity to calculate a relevance score between each LOS profile and the learner's profile. Third is recommended content. The top ranked LOS is pretended to the learner. Fourth is observe and get the feedback. The system captures implicit feedback, scrolling time spent, and explicit feedback, user rating. The learner's performance is measured using an intelligent assessment tool. Based on the feedback and performance, the weight in the learner's profile vector are dynamically updated. The cycle repeats. Okay. The system learns the learner profile convergence in action. The system learns the learner. Okay. Simulation of the learning process show that the algorithm is effective. Over multiple iterations, the weight in the learner's profile vector dynamically adjust based on the feedback and performance converging towards the learner's true learning style preference. Okay, visual and verbal dimension. Cross initial weight both are equal. Then learner's true preference for verbal content is right and reinforced. Crossover point. Here, active and reflective dimensions is talking about active is the upper one and the reflective is the lower one, number of iteration. I just don't understand is that is what he wants to tell with this graphic. Active learners are more and passive learners are less. The number of iterations is used less in reflective. Okay. Moreover, validating the framework, a real world study. To test the effectiveness of the integrated framework, an experiment was conducted with 100 undergraduate learners in a design and analysis of algorithm course. Huh. Group 1 G1 control, 50 learners. Group 2 experimental, used a standard e-learning portal with a one size fit all approach. The same content. Okay, group 2 G2, 50 learners used a new intelligent framework to same personalized content. Okay, personalized learning leads to higher learner satisfaction. Learners in group 2 who used the intelligence framework provided significantly higher rating when asked for explicit feedback on their learning experience compared to the control group. The framework delivers a marked improvement in learning outcomes. The ultimate test of the framework is its impact on performance. The learners in group 2 constantly achieved higher scores in assessment, demonstrating a deeper level knowledge acquisition. From one size fits all to a personalized intelligent future for e-learning. Summary of contribution: successfully designed and validated integrated framework addresses key weakness in modern e-learning, demonstrated that analyzing non-verbal cues provides a more accurate measure of learners' knowledge than traditional online assessment. Prove that an adaptive algorithm can effectively personalize content delivery to individual learning style. The experimental result confirmed that combining intelligent assessment with personal instruction significantly benefit the learner, proving both the effectiveness of the learning and overall user satisfaction in online and right. Okay, this was the end, and now we can conclude as like that. The Shobana BT wants that she has developed a framework that will do the intelligent adaptive learning based on the student needs. So this was the paper of Shobana BT on design of an intelligent and personalized e-learning framework using machine learning techniques. Thank you for watching.